Back in Chapter 2, we talked about something called the average rate of change. And the average rate of change, which was just a slope, was just change in y over change in x. It was just f of x minus f of a over x minus a. And it's just the slope formula written in a little bit different format. Well, suppose we want to consider the average rate of change over smaller and smaller intervals by letting x approach a. The limit of those averages is called an instantaneous rate of change. So what if I want to find the limit of the averages? Instantaneous rate of change. And the instantaneous rate of change is just the derivative. It's just the limit as x approaches a of f of x minus f of a all over x minus a. One way of finding the instantaneous rate of change of something is to find something called the instantaneous velocity. Well, one of the things you're going to learn in physics is that the first derivative of the height is just the velocity of an object. And the first derivative of the velocity, is just the acceleration. So the acceleration really ends up being something called the second derivative of the height. Keep that in the back of your head because that will come up again. So if an object is dropped from a height of 3,000 feet, its distance above the ground in feet after t seconds is given by the function h of t is equal to 3,000 minus 16t squared. Find the object's instantaneous velocity after 4 seconds. Okay, to find the instantaneous velocity, we're going to find the derivative at 4 seconds. So it's going to be the limit as x approaches 4 of, or I should not say x, but the variable is t, of the original function, 3,000 minus 16t squared, minus f of 4, or h of 4. Well, what do you get when you plug 4 back into this function? You're going to get 2,744. And we're going to divide that by t, make that look like a t minus 4. So we know that we got to get rid of this t minus 4 in the denominator, so there's got to be some factor canceling going on. So first of all, let's simplify. The numerator is going to become negative 16t squared plus 256. It still doesn't say t minus 4, but I bet I can factor negative 16 out from both of those terms, and I'm left with t squared minus 16. And then t squared minus 16 is going to factor into t plus 4, t minus 4. Look at that. Now the t minus 4s are going to cancel. Now I can find the limit as t approaches 4. So now I'm just going to take 4 and plug it in. 4 plus 4 is 8. And 8 times negative 16 is negative 128. And the velocity is going to be in feet per second. But why is the answer negative? Well, the reason that answer is negative is because the height is decreasing. You're going down. And so if you're going down, it's really telling you the magnitude and the direction. Where have I heard that before? In this last example, we're going to let P of t be the population of the U.S. at time t. The table shows approximate values of the population at mid-year between 1996 and 2004. Estimate the value of P prime of 2000. All right, in order to find P prime, we're going to find the averages with 2000. What I'm going to do is, because the function is P instead of F, we're going to find the limit as our time approaches 2000, because that's our A value, of P of t minus P 2000 divided by t minus 2000. So whichever function name they give you, that's what you're going to use. That's why in the previous problem we used h. In this one we're using p. So we're going to start with the average from 1996 to 2000. So we're going to do 282,192,000 minus 269,667. We're going to divide that by -4 because the time from 1996 to 2000 is -4. And we should get approximately 3,131,250. Now we're going to find the average from 1998 to 2000. And we're going to do the same thing. We're going to do the population in 1998 minus that of 2000. You're going to get a negative number, and you're going to divide that by -2. Because the difference between 1998 and 2000 is -2, you should get about 3,038,500. Now let's find the average from 2000 to 2002. So we're going to do 2000, the population in 2002 minus that of 2000, and divide that by +2, because it's going to be 2002 minus 2000. And you should get about 2,874,500. And last but not least, let's do the average here from 2000 to 2004. So we're going to do the population in 2004 minus the population in 2000 and divide that by 4, because that's the number of years between them. And we're going to get about 2,865,750. The limit as we're approaching 2000, look at what's happening to the numbers as you go down towards 2000, up towards 2000. They seem to be approaching, maybe, what's halfway between 3 million and 2.8 million? Well, it's probably about 2.9 million. Or what you can do is you can average those two values, and you would find out that we are approaching about 2 million. And this answer is actually 2 million people per year. That's the change in population per year. Change in pop per year. And that's what we were finding with our instantaneous rate of change.